Good morning and welcome to Past Virtual Summit 2020. I'm Chris Hyde, and this morning I'll be introducing you to Azure Databricks. But before we get started with that, I've got a couple of housekeeping notes for you. First off, please check out everything that PASS has to offer. Most importantly, we'd love to have your feedback on all the sessions, not just this one. So before next Friday, please submit, let everyone know how they did, things they could improve on for next time. We'd love to get your feedback to improve as speakers and to make this event as good as it can be for the future. So a few notes about me. The important thing here is on the bottom right. If you want to get a hold of me, you can use my Twitter handle. If you want to tell everyone how good the session is, again, use the Twitter handle. If there are things you think I could do better, though, well, that's what the email address is for. But seriously, if you have any questions after this session is over, please feel free to reach out to me using either method. I'd love to hear from you. So the genesis of this presentation started because earlier in the year I kept hearing about this cool new Databricks thing. And I saw a couple of presentations, I watched a couple of videos, but they really didn't help me understand what Databricks really was, what role it could play, what its capabilities were. So I wanted to develop kind of that true intro presentation that I wish I'd had, that kind of fills in those gaps for people. So right off the bat, this is a 100 to 200 level session. If you have any technical Databricks questions, please feel free to ask them in the comments, but I might not be able to answer them for you right away. I'm just beginning my Databricks journey as well, but I promise that I will get back to you, as best as I can. So with that out of the way, let's get started. What is this Azure Databricks thing anyway? But really, before we talk about that, we kind of have to answer the question, what is a data engineer? What is this new data engineering role that we've been hearing about? And even before that, we probably need to take another step back and make sure that everyone here understands what we mean by the term data warehouse. In particular, there's a term being used called the modern data warehouse. And let's talk a little bit about what that entails. So let's answer those two questions, and then we'll spend the rest of the session looking at some demos of how and why we might use Azure Databricks. Great, so at its most basic level, a data warehouse is a centralized repository of integrated data from one or more disparate sources. They store current and historical data, and they're used for reporting and analysis on that data. So this diagram is, a good traditional data warehouse. Let's say it's implemented in the Microsoft BI stack. We might have over on the left our different source systems, and we're using SSIS integration services to move our data to do an extract, load, and transform, or ETL process, to put that data into our data warehouse in the center. And then we'll serve that up to our end users. Maybe we're using SQL Server reporting services or Power BI for reports. Maybe we're using analysis services to expose a semantic layer to the user. But this is the kind of thing that we've been dealing with in the business intelligence world for quite some time now. But as an industry, we're starting to move towards this modern data warehouse architecture, which takes its cues from the big data world. So we can probably all agree that to some extent, the term big data is a bit of a buzzword at this point. But really at its heart, it was kind of intended to talk about the 3 V's, the volume of the data, the velocity at which it comes in, and the variety, all the different types of data sources that you might have. Now, what we're seeing is that even if we don't necessarily have the volume and velocity of true big data, a lot of us still have that full variety of data sources. So it's not just data coming from relational database systems. It's also text files, and maybe they're in CSV format or in JSON format, or whatever different format. But then we also have completely unstructured data like media files, web logs, things like that. And in the past, we spent a lot of time transforming all those different varieties of data. And we put them in a rigid structure and then move them into our data warehouse. But that's not necessarily the best way to do things these days, now that we have access to relatively cheap distributed computing. And we see a couple other examples here where we can bring in Cosmos, and maybe we're bringing in Kafka to ingest some of our real-time sensor data or other IoT appliances. But I think what we're seeing here is that Databricks kind of sits in the center of everything. And I'll come back to that point in a minute. Because now that we've talked about a data warehouse, let's talk about the role of a data engineer. This is a role that is becoming bigger and bigger. It's a key to this modern data warehouse architecture that we're talking about today. One thing you'll hear is that 80% of data science is really data engineering. And in fact, it's probably closer to 90%. In a way, this is analogous to traditional BI. That traditional business intelligence is probably 80 to 90% of ETL work. Same thing here with data science. It's all about wrangling the data and cleaning it up and ingesting it in a variety of different formats and turning it into a good model that our machine learning algorithms can use. So it's becoming very, very important to have all these data engineering skills. Another reason it's important is that the role of the traditional database administrator is evolving. So in the past, we had a lot of tasks that we're starting to see they're able to be automated away or done for us in the cloud. Things like backups, in the Azure cloud are handled for us natively. High availability. If any of you have ever had to build a log shipping solution to move data from one colo to another, well, that's not necessarily the easiest thing to do. But in Azure, with a couple of mouse clicks, the right settings, and a swipe of your credit card, you can set up geo-replicated high availability very easily. Even security features like encryption are mostly turnkey in the cloud, and even performance tuning, which is sort of one of the last bastions of traditional DBA work. You now have things like intelligent query processing and adaptive query processing that are able to do a large chunk of those tasks for us. So we really need to skill up in other areas of the data platform and the data ecosystem to ensure that we're going to have really good, compelling work for the future. So with all that out of the way, we've talked about a data warehouse, we've talked about the data engineering role. So now we're really ready to talk about Azure Databricks. So at its most basic level, Azure Databricks is the Azure implementation of a cloud-based product called simply Databricks. This Databricks product, it's really just a managed version of something called Apache Spark with a bunch of extra features on top. But that's not particularly helpful so far, right? So what is Spark? So it's a tool or a framework for processing very large amounts of data by distributing this processing across a large number of machines. Now, Spark is fully open source, so you could set it up yourself and run it for free if you're an expert in networking and container technologies and things like that. But we can do all that provisioning stuff in the Azure cloud with just a few mouse clicks here. Because it's in the cloud, we can spin up these Spark clusters very, very quickly, even very large clusters that have dozens, hundreds, potentially even thousands of processes. And then we can just run them only for as long as we need to process our data. And then we can shut them down so we're not paying for computing power that we're not using. We didn't have to set up dozens of servers in our data center only to handle a 30-minute ETL that runs every day, for example. We can just turn this on, only pay for the compute that we're actually using, turn it back off. So very efficient that way. So at its heart here, Azure Databricks is simply just a massively parallel data processing tool. And if we go back to the architecture diagram, we can see how it fits in the center of all these other technologies, sort of as the data processing engine. So I mentioned an ETL process earlier. These days, we're going to more of an ELT, extract, load, and then transform process. And I think in a lot of ways, Azure Databricks fits as the T in our ELT solution. So we're extracting data from the original sources, and we're perhaps using a tool like Azure Data Factory to load that data into our data lake. And then we're using Azure Databricks to do the heavy lifting and all the transformations of all this large disparate data, turning it into conformed, meaningful information. Now, the mechanism that we'll be using to do that are these Apache Spark notebooks. Now, I expect at this point many of you have dealt with notebooks, whether they're Python or R notebooks in Jupyter, or perhaps SQL notebooks in Azure Data Studio. But we also have the notebooks available in Azure Databricks, and they contain primarily the code that is driving the tasks we do in the engine. But we also, within our notebooks, are able to put markup language to explain what we're doing. We're able to store the data and store our results, whether they're numerical, whether they're graphical, nice visualizations. We can store them right in the notebook. And Azure Databricks provides a way for our entire team to share those notebooks and reproduce each other's work, see the results of each other's analyses. Very good, very collaborative environment. So I've listed here some of the things we might do. We might read and process very large files or very large numbers of smaller files, and then explore or query the data that's in there, analyze that data more deeply, perhaps do some visualizations on that data. And if a lot of that data is in vastly different formats in our data lake, we can also join it together. We can use notebooks to process live streams of data. We can even use it to train and evaluate our machine learning models. We can take a look at large graph data sets. One of the demos today, we'll look at those. And we've got several choices to use as languages within the notebooks. So I expect if you look at this list, you're familiar with at least one of these options. Python, Scala, R, and SQL are all available for us to use. And the great thing is we can mix and match these languages within the same notebook, and I'll show you how to do that in a little while. So let's go ahead and move over to the demo portion of the session. So I'm going to jump over to my Azure portal here. And the first thing we need to do is to create a workspace. Now, this is basically the Databricks appliance that's deployed to our Azure subscription. So I'm going to go ahead and create a resource. And we know there's hundreds of different resources available in the marketplace now. So the easiest thing to do is just start typing Databricks in the search. And here we go. We can hit the create button. All right, so the first thing we will need to choose is which of our resource groups do we want to attach this workspace to. Let's give it a name. So let's call this one Databricks Demo 2020 11/13, I think is today. I'll put this in the South Central region. That's the closest region in the US to where I am right now. And I'll set this to the premium tier. I'll review it and hit create. So this actually takes about, usually 5 to 7 minutes to set up the workspace. So like any good cooking show, I've gone ahead and set that up already. So we can see here is our Databricks service. And I can go ahead and launch the workspace here, and it brings up a browser-based interface where we can start working with Databricks. So the first thing we have to do is we have to create a cluster. So an Apache Spark cluster is that group of computers that are treated as a single machine, and they're going to handle the execution of the commands that we issue in our notebooks. So we've got a driver worker type of architecture. Because of that, the clusters allow the processing of data to be parallelized across many computers to improve scale and performance. So if we're ingesting, I don't know, 40,000 files, we've got 8 different worker nodes. Well, each worker node can work on 5,000 of those files, and we can parallelize this all at the same time. So I don't want to get too deep into the architecture today. This is really a basic level intro, but we've got the driver and worker nodes. The driver will send work to the worker nodes, and it'll instruct them to pull data from a specified data source or do particular processing pieces on a portion of our data set and return all the data together. So as I mentioned, we'll need to set up our cluster first. Now I've got one already running here, but let's just look at the creation interface quickly so you're familiar with it. I'll give it a name. I can choose standard or high concurrency. And I can choose from many different runtime versions here. If I zoom in, you can see that we have many different permutations of different versions of Spark, different versions of the Scarlet language, and whether or not we're going to be using GPU processing. So that's important to pick the right one. And then I can specify a different number of worker nodes. And I can also specify how powerful are each of these nodes. I've chosen kind of the lowest level here, just a 4-core, 14 gig memory machine, but I could choose much larger ones. And I could choose really as many as I want, as long as I've got the ability to pay for it. Now, I believe there is a soft cap when you're first playing with Databricks. I think it's currently set at 20. So if you really need more than 20 worker nodes, you'll have to put in a call to Microsoft to have them change that maximum on your account. But no big deal, it's very easy to do. So we've gone ahead and created that cluster already. This takes even a little longer than setting up the workspace, maybe 7 to 8 minutes. So I've got this set up and running beforehand. So let's go ahead and take a look at a few notebooks. So we'll go to our workspace here. Now, one thing we might want to do is just import a new set of notebooks. Maybe we've got them as a file. Maybe we've got just a URL, and these are publicly available notebooks. The 2 examples I'm going to show today are both publicly available, so I will drop the URL for these in the chat for the session so that if you're following along or if you want to look at these later, you can just drop the URL in here and bring them in yourself, work on the same notebooks that I'm using for the demos today. So let's go ahead and look at our first one. So we've got a CSV file that we want to take a look at. This is a pretty common use case, right? You've got a new file that's dropped into your lab, or it's put into your data lake, and you need to do some quick analysis and ingest it somewhere. So for those of you who aren't that familiar with the notebooks, they're structured into these different cells, as you can see. And you can run the cells one at a time, or you can run them in batches. Some of the cells, for example, this one contain code. This one just contains markup language. So let's go ahead and get started with our first data set. We've got some data that's coming from Wikipedia for this. It's just a number of different page views for each second, each timestamp, and kind of where the source is coming from. So the first thing we're going to look at here, we've got this little %fs. So anytime we're using a percent here, that's kind of a magic command. This is sort of a common abbreviation. So I'm going to be using some of the DBA utils file system library features to, first off, just take a look at what our files are. Okay, obviously we took a few seconds there to actually attach to our cluster, but once we did, it took less than a second to run. So here's the file we're going to concentrate on, this TSV. It's about 256 meg. Let's figure out what's in it. Let's use another one of those magic system commands. Let's use the file system head. This is going to let us look at the top 64K of the file that we want to ingest. And we can see we've got 3 different columns. We've got a timestamp, a site, and then a number of requests. We can see it's, I said we were looking at CSV files, but we see from the way this is spaced, it's really a TSV or a tab separated file. So when we want to read this in, we're going to need to add the option of a separator. Without that option, this command assumes that we're looking at a standard CSV, but we're looking at a tab. So let's go ahead and trigger the job to bring this data into a data frame. So that's the table-like object within Spark that we're going to use to take a look at the data. So we'll bring it in here. Took about a second to bring in. Let's look at what the schema looks like of the data that we've brought in. And we can see this didn't really turn out like we'd hoped. We've got 3 columns, yes, but they're named C0, C1, and C2, and everything came in as a string, and I'm pretty sure that we had some different data types in there. So let's take a quick look at the data. And we can see in our data frame here that okay, these are all strings and we don't like the column headings, but also that the column heading that's in the file came in as a line in our data set. So we want to take care of that. So let's tell it to use the file's header. And we won't look at the data here, we'll just show the schema. Okay, we can see we've now got our column names appropriately, but still the data types aren't quite right. Well, let's add another option to have Databricks go ahead and infer the schema for us. So it's going to read in all the data and then decide what it thinks is the best data type for each of our columns. So I'll go ahead and kick this off. This is likely to take about 13 seconds or so based on the number of worker nodes that I'm running. So let's give it a few seconds here. Get a chance for me to catch a drink. Great, 12 seconds, and we see now, okay, we figured out that first data, the first column is a timestamp, the last one is an integer. So great, our data now looks like it's supposed to. But we kind of know that if we're bringing in data once, we're going to bring in data again and again. We've just started looking at this file for the first time, but chances are there's going to be dozens or hundreds more of these files coming down our pipeline. So instead of having Databricks infer the schema every single time, we can actually create a structure ourselves and tell Databricks to use that particular schema structure on the import. So we'll set up a structure here with our different field types. I'll go ahead and run that. And then instead of using infer schema, we will use that right here. And so instead of 12 seconds, let's see, it took a quarter of a second. So that's going to be much more usable going forward. Let's take a quick look at our data. We should have 8 partitions of about 1 million rows apiece. So bringing all those in a quarter of a second, that's pretty quick. But the kind of volume that we might want to use with Databricks would be dozens, hundreds of files, much larger than this. So we would really want to be able to scale out kind of on demand anytime we wanted. Let's just spin up all those processors and read all that data as quickly as we can again, and then turn off our processing power. All right, so that was CSVs. So let's move on to another file type, which is JSON documents. So some of you may have used JSON in SQL Server and found that it's not always the easiest thing to use. I think you might like this a little better. So again, let's look at our files that are available. Now, in this case, this is going to be data about a lot of edits to the Wikipedia pages rather than the data that's been requested. And if you think of all the different things that you can do on a Wikipedia edit, you can add text, you can take it away, you can add a file or a picture or a media file, all sorts of things. And it would be very difficult to have a single data structure that easily encompasses all the different things you might do in that case. So one thing we can do is store that data in JSON format. And all the tags in there are sort of self-documenting our data within the data field. So let's take a look at first 64K here. And we'll see a little bit what we mean. Not easy to see here, but we see a lot of, okay, here's a URL, here's an attribute, here's a particular page name, so on and so forth. We can see that, the field names are part of our data. So our command to read this in looks very similar. Let's pull this in. We'll go ahead and infer the schema as we're going. And we see, okay, this has a hierarchical structure. We've got all our different nodes, but the geocoding node actually has an extra step, an extra level beneath it. So querying that stuff in T-SQL once you've got JSON data in your database isn't necessarily the easiest thing, but we've got a way to do that in Databricks that I think you'll like. So first off, I want to draw your attention to the top here that says, next to the notebook name, it says Python. So this is a Python notebook. But we'd love to be able to use standard ANSI SQL to query this data frame that we've created. So we can do that if we create a view on top of the data frame. And then we can issue a simple ANSI SQL command against it. Now, you'll notice here we've got another magic command. This is the piece that tells our notebook engine, hey, this cell, treat this as SQL. Don't treat it as Python like the rest of the notebook. Treat the code in here as though it was SQL. So we can go ahead and issue a simple select and get back the top 1,000 rows of our data. And that looks pretty standard, except when we go over here to the geocoding column, because that was a next level, everything within that geocoding column looks itself like a type of JSON data. But we can actually drill down into that. So geocoding.city will drill down to the city node, .latitude drills down to the latitude, so on and so forth. And this is a very easy to use method to interrogate the JSON data and even start transforming it for us. So I like this. I think this is pretty cool. Now, again, we're probably not seeing, only one JSON document. We're probably seeing, dozens, hundreds of these come into us. So again, we can define a schema, define a structure up front using the same syntax. Just note that, that geocoding node, is a structure within a structure, and that will allow us to go ahead and pull in that data very, very quickly. Yeah, again, less than a quarter of a second for that, 4 megabyte of semi-structured JSON data. So pretty cool. All right, so one last demo for you today. We're going to look at the capability of graph frames. So data that's stored as a graph is stored with vertices and edges between these vertices. So the example here we're looking at is kind of nonstop flights from one airport to another in the US. So our vertices are the different airports. So Houston, Seattle, and the edge is the one-way flight from Houston to Seattle. So this is going to really be efficient if we use a special type of data frame called a graph frame to hold this data. Now, the graph frame is not installed by default as part of the code that is turned on when we set up our cluster. So we're going to need to go into our cluster and go over to the Libraries tab. And I've gone ahead and set this up already, but we'll show you how to install a new package. We're going to pull it from Maven, and I'll just do a quick search for packages and see everything in here that's available. Well, it's going to be much easier if we filter this a little bit. And here's our graph frames. And then the mistake I often make is I just go ahead and hit select. But what that hasn't taken into account is all the different versions of the graph frames package. In the same way that when we set up our cluster, we were picking a specific version of Spark and a specific version of Scala, we need to pick a version of the graph frames package here that matches the version of Spark and Scala that we used. I'm going to make sure here that I pick the right one. Okay, that's actually the settings I used. Hit select, and great, it'll take a few seconds to go ahead and install the library, and then I can reference that from within my notebook. So let's go ahead and create some pointers to our files. And then we'll start reading that data in, and we'll put some views on it using the register temp table command. Now, officially, this has been deprecated in Scala, but it's going to be good for our purposes today. Yeah, so just to make sure anybody running this at home, you'll want to use a slightly older version of Scala, probably 2.1 and Spark, I think 2.4 or earlier to get this specific demo to work for you when you're running it at home. Okay, let's go ahead and create all the geographic data. And then we'll take a quick look at what that looks like. So we've got some more context for you. Okay, so here's our data. We've got flights, in this case, going from Minneapolis to International Falls. We've got the 3-letter code for each of our source and destination city. The really important thing in here is the delay column. If it's negative, that means our flight left early. If it's 0, the flight left right on time, or any positive integer, that's the number of minutes late that the flight was. So we've imported this data. Let's go ahead and build our graph. So we'll build our vertices and our edges. And we see all the different cities are our vertices. All the individual flights are the edges of our graph. And let's go ahead and make that graph frame from it. Okay, we've now got a graph frame. Let's go ahead and start querying it. So very simple, very simply, how many vertices, how many edges do we have? So nearly 300 different airports, nearly 1.4 million different flights. What's the longest delay in there? All the flights. Wow, that's more than 24 hours. I certainly would not want to have been booked on this flight. That's not great. Let's see how on time versus early flights look. Let's throw a couple of filters in there. Wow, we can see that that's probably about 40% or so of our flights were delayed. That's not great. Let me move along. We can keep doing some more analysis. And because this notebook is sitting in our workspace, anybody else that can work in this workspace can be following along, can go in and make edits. They can reproduce the results that we're getting. They can look over our code as a peer review to make sure that we didn't introduce any bugs or any other kind of logical errors in our analysis. So everybody that has access to this workspace can work on the same document in a collaborative fashion. So that's pretty super. Let's look at our flights. Let's throw in a filter, just flights out of San Francisco. Let's see which destinations have typically large delays. All right, so don't fly to Oklahoma City or Jacksonville or Colorado Springs because you might be delayed for nearly an hour on average. All right, let's look at another example. Let's see, which of our destinations tend to have delays a lot. Well, we see in the U.S., certain states, New York, West Virginia, South Dakota, they seem to have, a pretty large volume of delays here. Let's look specifically at delays from a particular airport. Let's say Pass Summit this year was in its usual Seattle location, and we're going to be flying home from, a good week of learning and networking. Well, where are we likely to be delayed on our one-stop flight? Well, any flights to California, it's going to be a lot of delays. We can see we've actually got a surprisingly low amount of choices for a nonstop flight. Now let's skip down a little bit. Let's see, where do I want to go? I want to look at, let's look at some of our direct flights. So let's go ahead and look at, let's find all of our direct flights between Seattle and San Francisco. So we'll go ahead and traverse the graph. Sorry, I'm looking at the wrong one. So here, dozens of flights between San Francisco and Seattle. But when we switch Seattle out for Buffalo, no flights at all, direct from San Francisco to Buffalo. So that's our path length of 1. But if we bump up our path length to 2, maybe we've got some flights with a layover. Let's see if we have any of those. Well, this probably won't be a surprise if you're reading the next line of Markdown, but we do have some that go through Minneapolis or through Boston as well. So yeah, this is a great tool for us to be able to traverse through graph data. So that's really all the demos that I had to show you today. I wanted to leave you with a slide with a number of resources. This presentation will be up on my GitHub account. You can download the slide deck from there, and I'll make sure that there's a link to the demos that are available as well. I want to point out these really good tutorials on Microsoft Learn. Learn has really taken a big leap over the past year, 18 months, with what's available for us to use and practice with and learn from. So I'd really recommend, as you're starting to use Databricks, go ahead and look at these 2 tutorials in particular. And then another good step is this YouTube account by a company out of the UK called Advancing Analytics. Some really good presenters, and a year or 2 ago, they had this series called A Month of Azure Databricks, where for every day or every other day, they produced a new video, 10 minutes or so, introducing you to another step along your Databricks journey. So I'd really recommend, if you're interested in going further with Databricks, that's going to be a great place to go to and watch all those videos. They're really good. So with that, I'm done. Thank you very much for your time. And I believe we've got some time left over for questions. So please go ahead and type them in, and I'll answer as best as I can. Remember, this is focused on a 100 to 200 level sort of session. So anything higher, I'll probably have to get back with you later. But again, thank you very much for having me. I hope this has been helpful. I really hope that now you're starting to get an understanding of what Databricks is used for. It's really that massively parallel transformation engine. Again, thank you very much for having me, and I look forward to taking your questions in the chat. Thank you.